The year is 232 million BC. The world is burning. A red sun hangs low over the supercontinent of Pangea. The air is thick. It tastes of copper and sulfur. A haze of volcanic dust chokes the sky, turning the horizon a bruised, angry purple. The heat is oppressive. It presses down like a physical weight. On these ancient plains, the temperature sits at a sweltering 6 degrees Celsius, warmer than the world you know today. There is no ice at the poles. There is no respite from the warmth. Through the heat shimmer, something moves. It is small. It is quick. It darts through the shadows of the giant ferns that blanket the ground. This is Eoraptor, the dawn thief. It is not a giant, not yet. It weighs barely 10 kilograms. From nose to tail, it measures perhaps 1.2 meters. It is sleek, bipedal. It runs on 2 legs with a nervous, jerky energy, its head snapping side to side, scanning for danger. And there is danger everywhere. The ground beneath its clawed feet trembles. A low rumble vibrates through the basalt rock. Miles away, a rift in the earth has opened again, spewing fresh lava onto the surface. The Eoraptor pauses. It lifts 1 foot. It listens. The silence of the deep past is not truly silent. It is filled with the hiss of steam vents, the crack of dry wood, the distant roar of creatures far larger, far heavier, and far more terrible than this small, anxious animal. This is a world in recovery. Only 20 million years ago, a mere blink in geological time, the Earth nearly died. The Great Dying, the Permian Triassic Extinction event. It was the single most catastrophic loss of life in our planet's history. 96% of all marine species vanished. 70% of all land vertebrates were erased. The slate was wiped clean. The biological hard drive was formatted. And now, life is trying to find a way back. The ecosystems are fractured. The food webs are chaotic. The world is a harsh, unforgiving frontier of dust and magma. And in this hostile crucible, the ancestors of the dinosaurs are nothing more than underdogs. They are not the rulers. They are the refugees. They scurry in the undergrowth, hiding from the crocodile-line archosaurs, the true masters of the Triassic. They are small. They are insignificant. They are vulnerable. Watch the Eoraptor run. It snatches a large beetle from a fern frond. It swallows it whole. It does not stop moving. To stop is to die. It is agile, yes. It is fast, but it is surrounded by monsters. The Saurosuchus, a 4-legged predator the size of a modern truck, rules these floodplains. The Postosuchus, an armored tank of a creature, crushes bone with a single bite. Against these titans, the Eoraptor seems like a biological footnote, an evolutionary experiment destined to fail. But it will not fail. Look closely at this small creature. Look at the way it stands. Its legs are pulled under its body, not splayed out to the side like a lizard. It breathes efficiently, its lungs gulping down the thin, oxygen-poor air with an ease that its rivals cannot match. Its metabolism burns hot. It is waiting. It is preparing. The dust swirls. The sun beats down. The Eoraptor vanishes into the ferns, a ghost in the machine of deep time. It does not know that it carries the genetic code of kings. It does not know that its descendants will grow to the size of buildings, that they will shake the earth with their footsteps, that they will conquer the air, the land, and the sea, that they will endure for an eternity. 165 million years, that is how long they will reign. It is a number so vast it defies comprehension. Human civilization has existed for 6,000 years. The dinosaurs ruled for 27,000 times that length. They will see continents break apart. They will see oceans born and mountains rise. They will weather ice ages and greenhouse spikes. They will become the most successful, most diverse, most dominant group of large land animals the planet has ever seen. But why? Why them? Why not the crocodile-line archosaurs? Why not the heavy, armored dicynodonts? Why did this specific lineage, starting as small, frightened opportunists in the shadows of the Triassic, rise to absolute power? Was it destiny? Was it luck? Was it a superior design? The answer is hidden in the stones. It is written in the bone beds of Argentina and the ghost ranches of New Mexico. It is a story of catastrophic luck and evolutionary genius. A story of how the world tried to kill them again and again, and how each attempt only made them stronger. So what was it, really, that allowed these creatures to not merely survive, but to dominate every continent, every ecosystem, every corner of this ancient world for 165 million years? If you enjoy journeys like this one, you consider subscribing. There is much more waiting for you. To understand the unprecedented reign of the dinosaurs, we must first look at the graveyard from which they emerged. The history of the Mesozoic era, the age of reptiles, is bracketed by death. It began with an end, and it ended with an end. But it is the specific nature of these extinctions that carved the path for dinosaur dominance. Let us go back to the beginning. The Permian Triassic extinction event 252 million years ago was the closest life on Earth ever came to total annihilation. It is often called the Great Dying. For a period of perhaps 60,000 years, a heartbeat in geological time, massive volcanic eruptions in what is now Siberia released oceans of lava and inconceivable amounts of carbon dioxide into the atmosphere. The global temperature spiked, the oceans acidified, the delicate chains of life shattered. When the smoke cleared, 96% of marine species and 70% of terrestrial vertebrate species were gone. The scale of this catastrophe is difficult to comprehend. The Siberian Traps eruptions lasted for nearly 1 million years, covering an area larger than Western Europe with lava up to 3 kilometers thick. The volcanic activity released an estimated 100,000 gigatons of carbon dioxide, along with sulfur dioxide and methane. The temperature of the oceans rose by approximately 8 degrees Celsius. In the deepest waters, oxygen disappeared almost entirely, creating vast dead zones. On land, acid rain fell for centuries. The ozone layer thinned, bathing the surface in ultraviolet radiation. It was, by every measure, an apocalypse. What survived this hell was reduced to the bare essentials: small, generalist species, scavengers, creatures that could tolerate heat, could go without food for extended periods, and could breed quickly when conditions improved. The survivors inherited a world that was, in many ways, sterile, a blank canvas waiting to be painted. The world that remained was empty. It was broken. But nature abhors a vacuum. Into this emptiness stepped the archosaurs, the ruling reptiles. This group split into two main lineages: the Crurotarsans, which led to modern crocodiles, and the Avametatarsalia, which led to dinosaurs and pterosaurs. For the first 30 million years of the Triassic, it was the Crurotarsans who held the crown. They were diverse, abundant, and terrifyingly effective. Then came the rain. Approximately 232 million years ago, a strange climatic anomaly occurred. It is known as the Carnian pluvial episode, for reasons likely linked to the eruption of the Wrangellia, large igneous province in present-day Western Canada. The arid, desert-like climate of Pangea suddenly shifted. It began to rain, and it kept raining on and off for nearly 2 million years. The dry, red deserts turned into humid basins. The flora shifted from drought-resistant seed ferns to lush, water-loving plants. This was the turning point. The fossil record shows that before the Carnian pluvial episode, dinosaurs were rare, making up perhaps 5% of the terrestrial vertebrate fauna. After the rains ceased, they had exploded in diversity and number. Something about that wet, chaotic world favored them. Perhaps it was the change in vegetation. Perhaps it was the instability itself. A modern paleontological research offers clues. In 2018, a team led by Massimo Bernardi examined fossil footprints from the Dolomites in northern Italy, dating to the Carnian period. They found that before the pluvial episode, the footprints were overwhelmingly from Crurotarsan archosaurs. After the episode, dinosaur tracks dominated. The shift was dramatic and undeniable. The rains had triggered a revolution. Why? One theory suggests that the humid conditions favored smaller, more agile animals. Dinosaurs, with their upright posture, could move through dense undergrowth and flooded terrain more efficiently than their sprawling competitors. Another theory points to the change in plant life. The new flora may have been easier for dinosaurs to digest, giving them an energetic advantage. Whatever the cause, the dinosaurs were no longer hiding. They were stepping into the light, but they were not yet kings. That coronation required one more catastrophe. But the true coronation of the dinosaurs came 31 million years later. At the boundary of the Triassic and Jurassic periods, 201 million years ago, disaster struck again. The Central Atlantic Magmatic Province, or CAMP, erupted as Pangea began to tear itself apart. Lava covered an area of 11 million square kilometers. Carbon dioxide levels doubled, then tripled. The oceans became toxic. This event, the Triassic-Jurassic extinction, wiped out 76% of all species. Crucially, it wiped out almost all the Crurotarsans. The crocodile-line archosaurs, who had ruled the Triassic with an iron fist, vanished, leaving only a few lineages of small ancestral crocodiles. The dinosaurs, however, barely flinched. They walked through the fire and the acid rain almost unscathed. When the Jurassic dawn broke, they looked around at a world that was suddenly, miraculously, theirs alone. Why did one group die while another survived? This question has haunted paleontologists for decades. Recent research suggests the answer lies in metabolic flexibility. The Crurotarsans were specialists, finely tuned to the hot, dry Triassic environment. When that environment collapsed, they had nowhere to go. The dinosaurs, by contrast, were generalists. Their efficient respiratory systems allowed them to tolerate a wider range of oxygen levels and temperatures. Their rapid growth rates meant they could reproduce quickly, taking advantage of brief windows of stability. And crucially, many early dinosaurs were omnivorous or opportunistic feeders, able to switch food sources when plants or prey became scarce. The Triassic-Jurassic boundary is marked in the rock record by a thin layer of carbon-rich sediment, evidence of mass death and ecosystem collapse. Below this line, the fossil assemblages are diverse, chaotic. Above it, the story simplifies. The dinosaurs dominate, the competition is gone. Why did they survive when others perished? Paleontologists like Sterling Nesbitt and Paul Sereno have spent decades analyzing the bones of early dinosaurs to answer this question. They point to a suite of anatomical innovations that gave dinosaurs a critical edge. The first was posture. Unlike the sprawling lizards and amphibians of the time, dinosaurs walked upright. Their legs were tucked vertically beneath their hips like pillars. This seemingly simple change was revolutionary. It allowed for more efficient locomotion. It meant they could breathe and run at the same time, something a sprawling lizard cannot easily do, as its side-to-side motion compresses its lungs. An upright dinosaur had greater stamina. It could cover vast distances in search of food or mates. To appreciate the significance of this change, consider the mechanics. When a lizard runs, its body bends from side to side in a sinusoidal wave. This lateral undulation compresses the ribcage on alternating sides, making it nearly impossible to breathe while running. A lizard must stop to catch its breath. But a dinosaur, with its legs directly beneath its body, moved in a parasagittal plane, back and forth, not side to side. Its ribcage remained stable. It could breathe continuously while moving. This gave dinosaurs extraordinary endurance. They could pursue prey over long distances, migrate across vast territories, and flee predators without collapsing from oxygen debt. It was a simple anatomical shift with profound ecological consequences. The second advantage was hidden deep inside their bones. Paleontologist Robert Bakker, a maverick in the field, was among the first to aggressively argue that dinosaurs were not sluggish, cold-blooded reptiles, but active, warm-blooded animals, endotherms. While the debate continues, evidence suggests that many dinosaurs possessed high metabolic rates. They grew fast, or they lived fast. Bakker's 1968 paper, titled The Superiority of Dinosaurs, was revolutionary and controversial. He pointed to the bone structure of dinosaurs, which showed dense vascularization, networks of blood vessels that suggested rapid growth and high metabolic activity. He noted the predator-prey ratios found in fossil assemblages. Warm-blooded predators require far more food than cold-blooded ones, and the ratios in dinosaur ecosystems matched those of modern mammalian ecosystems, not reptilian ones. He also pointed to their posture and activity levels, which seemed incompatible with a sluggish, cold-blooded lifestyle. The debate rages on, but the evidence continues to mount. In 2014, a study analyzing growth rings in dinosaur bones concluded that most species grew at rates intermediate between modern reptiles and mammals, with some theropods approaching mammalian rates. This suggests they were mesotherms, neither fully cold-blooded nor fully warm-blooded, but somewhere in between, capable of generating internal heat but also regulating body temperature through behavior. This metabolic flexibility may have been yet another key to their survival. But perhaps their greatest secret weapon was their breath. Dinosaurs possessed a highly efficient, bird-like respiratory system. It is called unidirectional airflow. In mammals like us, air flows in and out of the same tubes, mixing fresh oxygen with stale carbon dioxide. It is inefficient. But dinosaurs, like birds today, had a system of air sacs that kept oxygen-rich air flowing through their lungs continuously, even when they exhaled. Consider the atmosphere of the Mesozoic. During the Triassic, oxygen levels were perilously low, perhaps as low as 15 or 16%, compared to today's 21%. At sea level, the air would have felt as thin as it does at the top of a high mountain today. For animals with inefficient lungs, this was a constant struggle. But for the dinosaurs, with their super-efficient air sacs, the thin air was enough. They could thrive where others gasped. As oxygen levels slowly rose through the Jurassic to 26% and reached a peak of 30% in the Cretaceous, this system allowed them to grow to titanic sizes, fueling bodies that defied gravity. The fossil evidence for this respiratory system is compelling. In 2005, the paleontologist Patrick O'Connor and his team discovered fossilized air sac systems in the bones of several dinosaur species, including the theropod Majungasaurus and the sauropod Eoraptor. The bones showed the same hollowed-out structures, the same pneumatic features found in modern birds. This was not convergent evolution, this was inheritance. The dinosaurs had invented this system, and their descendants, the birds, still use it today. It is one of the most efficient respiratory designs in the animal kingdom, and it gave the dinosaurs a profound advantage in the low-oxygen world of the Triassic and early Jurassic. The history of dinosaur discovery is itself a saga of revelation. In the 19th century, the fossil hunter Mary Anning scoured the cliffs of Lyme Regis in England, uncovering the first ichthyosaurs and plesiosaurs, hinting at a world of ancient monsters. Later, the Bone Wars between American paleontologists Othniel Charles Marsh and Edward Drinker Cope fueled a frantic rush to uncover the American West. They named hundreds of species, Allosaurus, Stegosaurus, Triceratops, often in a bitter rivalry that destroyed lives but built the foundations of modern paleontology. Today, we look to sites like the Ichigualasto Formation in Argentina, where the oldest dinosaur fossils, dating back 231 million years, are preserved in exquisite detail. We look to the Ghost Ranch in New Mexico, where hundreds of Chilophysis skeletons were found tangled together, victims of a flash flood, revealing their social nature. We look to the painted deserts of the Chinle Formation, tracing the slow, steady rise of these animals through the strata of deep time. Each of these sites tells a piece of the story. The Ischigualasto Formation, located in the Valle de la Luna, the Valley of the Moon, is a desolate and windswept badlands where the oldest known dinosaurs walked. Here, paleontologists have found Eoraptor, Herrerasaurus, and Pisanosaurus, creatures from the very dawn of the dinosaur age, preserved in volcanic ash and river sediments. The Ghost Ranch site, discovered in 1947, contained over 1,000 individual Chilophysis specimens, ranging from juveniles to adults, all buried together in a single catastrophic event. This mass death assemblage provided unprecedented insight into the anatomy, growth patterns, and social behavior of early dinosaurs. And the Chinle Formation, stretching across the American Southwest, is a treasure trove of Triassic life, documenting the transition from a world ruled by crurotarsans to one ruled by dinosaurs. The work continues. Every year, new species are named, new insights emerge. In 2023 alone, paleontologists described over 40 new dinosaur species, from tiny feathered theropods in China to massive long-necked sauropods in South America. The science is accelerating, our understanding deepens, but the fundamental truth remains unchanged. The science is clear. Dinosaurs were not biological accidents. They were biological machines, refined by millions of years of evolutionary pressure. They were built for efficiency, they were built for growth, and they were built to survive the worst the planet could throw at them. Until, of course, the one thing happened that they could not adapt to. Let us now close our eyes to the present and drift back. Let us walk the soil of the ancient Earth. The journey is long, spanning 3 distinct worlds, each with its own scent, its own light, its own terrors and wonders. We begin on the supercontinent of Pangea. It is a colossal landmass, C-shaped, straddling the equator. Because all the land is fused together, the interior is vast and far from the cooling influence of the ocean. It is a world of extremes. The center of the continent is a harsh, arid desert painted in shades of rust and ochre. The heat here is a physical presence. It shimmers off the red rocks, distorting the horizon. The air smells of dry dust and the sharp, metallic tang of oxidized iron. On the edges of this desert, where the seasonal monsoons bring life, there are great savannas of ferns and horsetails. There is no grass. Grass has not evolved yet. The ground is carpeted in green, with scratchy, primitive plants that crunch underfoot. The trees are strange to our eyes, giant araucarias, monkey puzzle trees, and cycads with thick, rough trunks and stiff, palm-like fronds. They stand like silent sentinels in the heavy, warm air. The sky is a washed-out pale blue, hazed by dust that hangs perpetually in the air. The clouds, when they form, are thin and ragged, torn by hot winds that sweep across the continental interior. When rain does come, it arrives with violence. The dry riverbeds become raging torrents within minutes, carving fresh channels through the red earth, carrying the bones of the dead downstream to rest in sediment that will one day become fossil beds for curious primates to excavate. But for now, the rivers run fast and deadly, and then, just as quickly, they vanish, leaving only cracked mud and the smell of wet stone baking under the relentless sun. In the shadows of the cycad groves, life clings to survival. Giant dragonflies, with wingspans approaching 1/2 meter, drone through the humid air near water sources. Their iridescent wings catch the light, flashing blue and green. Beetles the size of a human fist crawl over fallen logs, their mandibles working ceaselessly. The invertebrates of this world are large, alien, and abundant. They are the foundation of the food web, and they are everywhere. The silence is profound. There are no birds singing in the canopy. The only sounds are the rustle of the wind in the dry fronds, the buzz of ancient insects, and the hiss of reptiles. In the heat of the day, a pack of Colophysis moves through a dry riverbed. They are lean, agile hunters, roughly 3 meters long, with hollow bones and snake-like necks. Their scales are patterned in mottled browns and greens, blending perfectly with the shadows. They move with a fluid, bird-like grace, heads bobbing, large eyes scanning for movement. They are hunting the early ancestors of mammals, small, shrew-like creatures that scurry into burrows at the first vibration of a footstep. These mammals are nocturnal, terrified, living their lives in the dark, waiting for a dawn that is millions of years away. Nearby, a Eoraptor stalks. It is heavier, more primitive, a brawler of the Triassic plains. It has a boxy skull and serrated teeth designed to slice through flesh. The air grows still. The smell of ozone builds. A storm is coming. Lightning flashes over the volcanic ridges in the distance, illuminating a world that is harsh, dry, and waiting for change. At night, the temperature drops sharply. The lack of moisture in the air means the heat escapes quickly into the void of space. The stars blaze overhead, more brilliant than any modern human will ever see, undimmed by light pollution or atmospheric haze. The Milky Way stretches like a river of light across the sky. In the darkness, the small mammals emerge from their burrows, their whiskers twitching, their eyes huge and adapted to the dark. They are the future, but they do not know it yet. For now, they are prey. They are food. They are insignificant. This Triassic world is a world of waiting, a world poised on the edge of transformation. The volcanic activity continues in pulses. The air tastes of sulfur. The ground trembles. And through it all, the early dinosaurs endure, adapt, and slowly, imperceptibly, begin their rise. Time accelerates. The world fractures. Pangea is tearing apart. The Atlantic Ocean is born as a narrow, jagged rift, filling with seawater. The climate softens. The brutal extremes of the Triassic give way to a warm, humid, lush greenhouse world. The global temperature hovers around 4 degrees Celsius, warmer than today. There are no polar ice caps. Forests stretch from pole to pole. This is the age of giants. The air is rich and heavy with the scent of pine resin and damp earth. The forests are colossal, cathedral-like spaces filled with filtered green light. Ferns grow to the size of trees. Ginkgo trees drop their fan-shaped leaves in golden carpets. The light here is different. It is softer, diffused through layers of canopy. Shafts of sunlight pierce the foliage like golden spears, illuminating patches of forest floor where moss and liverwort grow in thick, spongy mats. The smell is intoxicating, a complex blend of decomposing vegetation, fresh growth, and the resinous perfume of conifers. The humidity is constant, wrapping around you like a warm, damp blanket. Water drips from the leaves. It pools in the hollows of ancient logs. It sustains an explosion of life. The sounds of the Jurassic are a symphony. The wind sighs through the branches. Water trickles in hidden streams. Insects hum in constant layered drones. And then, cutting through it all, the calls of the dinosaurs. Some are low-frequency rumbles, felt in the chest more than heard, traveling for kilometers through the dense air. Others are sharp, high-pitched barks and hoots, territorial displays echoing through the trees. And here, the earth shakes. A deep, rhythmic thrumming travels through the soles of your feet. It is a sound felt more than heard. Emerging from the mist is a Brachiosaurus. It is a living mountain. It stands 13 meters tall at the shoulder, its long neck reaching up 26 meters into the canopy to strip the highest branches. It weighs 50 tons. Its skin is thick, leathery, pebbled like a basketball, grey and slate blue in the filtered light. It moves with a slow inevitability, a creature operating on a timescale of its own. Further down in the clearing, a diplodocus herd grazes. They are suspension bridges of flesh and bone, 27 meters long, their whip-like tails cracking the air to communicate or warn off predators. They strip the ferns with peg-like teeth, their massive guts rumbling as they ferment the tough vegetation. So the social structure of these herds is complex. The adults form a protective ring around the juveniles, who are still vulnerable to predators despite their size. They communicate through body language, the position of the tail, the angle of the neck, the low rumbling calls that resonate through their massive bodies. A young diplodocus, perhaps 5 years old and already 10 meters long, stays close to its mother. It will not reach full size for another decade. Growth is slow, steady, relentless. Near the river's edge, pterosaurs glide on leathery wings, their shadows flickering across the water. They are fishing, diving with precision to snatch fish from the shallows. The river itself is a highway of life. Giant lungfish lurk in the murky depths. Freshwater sharks patrol the channels. Crocodilians, survivors of the end Triassic extinction, bask on the muddy banks, their eyes half closed, waiting with the infinite patience of ambush predators. In the dappled sunlight, we are Stegosaurus lumbers. It is a bizarre, magnificent animal. 17 kite-shaped bony plates run down its back in 2 alternating rows. They flush pink with blood, pumping heat away from its body, or flushing bright red to intimidate a rival. Its tail ends in 4-meter-long spikes, the thagomizer, a weapon capable of piercing bone. It watches warily as an Allosaurus, the lion of the Jurassic, prowls the forest edge. The predator is 9 meters of muscle and claw, its eyes crested with bony ridges. Its jaw capable of opening extraordinarily wide to deliver a hatchet-like blow. This is a world of predator and prey in perfect, terrible balance. The Allosaurus is patient. It has been tracking this Stegosaurus for hours, waiting for a moment of weakness. But the herbivore is healthy, alert, and armed. The standoff continues. Eventually, the Allosaurus turns away, melting back into the forest shadows. There will be easier prey. Perhaps a young sauropod separated from the herd. And perhaps a sick Camptosaurus, too slow to escape. The Jurassic is abundant, but it is not forgiving. Every day is a negotiation between hunger and survival. As the sun sets over the Jurassic world, the sky turns shades of orange and deep purple. The temperature barely drops. The greenhouse effect keeps the nights warm. The diurnal dinosaurs settle down to rest, while the nocturnal hunters begin to stir. Small theropods, no larger than chickens, dart through the underbrush, hunting insects and small vertebrates. The forest never truly sleeps. It simply changes shifts. The continents drift further apart, taking on shapes that are almost familiar. The Atlantic widens. South America breaks from Africa. A massive inland sea, the Western Interior Seaway, splits North America in two, a shallow, warm ocean teeming with marine reptiles. It is 800 kilometers wide and 800 meters deep, a blue scar across the continent. Well, the world is exploding with color. For the first time, flowers bloom. Magnolias, lilies, and ancestors of the rose appear, bringing splashes of pink, white, and yellow to the green landscape. Insects evolve to pollinate them. The air buzzes with bees. The smell is sweet, complex, perfumed. This floral revolution transforms everything. The angiosperms, the flowering plants, spread rapidly, outcompeting the older gymnosperms in many environments. They grow faster, reproduce more efficiently, and offer new food sources. Fruits appear for the first time, fleshy packages designed to be eaten and dispersed by animals. The co-evolution between plants and dinosaurs accelerates. Some dinosaurs develop specialized beaks and teeth to exploit these new resources. The ecosystems become richer, more layered, more complex than ever before. The seasons are more pronounced in the Cretaceous. Even in the tropics, there are wet and dry periods. In the higher latitudes, places that will one day be Montana and Alberta, there are cool winters where frost touches the ground. But even here, in these polar regions, dinosaurs thrive. Herds of hadrosaurs migrate with the seasons, following the vegetation. Predatory tyrannosaurs, insulated with primitive feathers, patrol the twilight forests, hunting in the extended dusk of the high-latitude summer. The dinosaurs here are the ultimate iterations of their lines. In the coastal swamps of what will become Egypt, the Spinosaurus rules. It is longer even than the T-Rex, perhaps 15 meters or more, with a massive sail on its back and a snout like a crocodile. It wades into the river, hunting giant sawfish, a semi-aquatic dragon. The sail on its back is both functional and spectacular. It may have been used for thermoregulation, catching the morning sun to warm its massive body. Or perhaps it was a display structure, flushing with blood to signal dominance or attract mates. Either way, it is a sight to behold, a living sail cutting through the water, hunting in the murky rivers that drain into the Tethys Sea. The Spinosaurus is unlike any other predator. It is a specialist, adapted to an aquatic lifestyle that no other large theropod has attempted. Its teeth are conical, designed for gripping slippery prey rather than slicing flesh. Its nostrils are positioned high on its skull, allowing it to submerge while still breathing. It is evolution experimenting, pushing boundaries, creating something entirely new. On the plains of South America, the Argentinosaurus shakes the bedrock. It is the largest land animal to ever exist. It stretches 35 meters long and weighs a staggering 80 tons. A single vertebra is the size of a human adult. It has no natural predators once fully grown. It is a force of nature, a walking ecosystem. To watch an Argentinosaurus move is to witness something almost geological in scale. Each footstep compresses the earth, leaving depressions that fill with water and become temporary ponds. Its heart, the size of a small car, pumps blood through a circulatory system that defies comprehension. The pressure required to push blood up that impossibly long neck is immense. Its digestive system is a fermentation vat, processing tons of vegetation daily, producing methane as a byproduct. Some scientists theorize that the collective flatulence of Cretaceous sauropods may have contributed measurably to the greenhouse gases of the period, helping to maintain the warm global climate. This creature lives on a different timescale. It takes decades to reach full size. It may live for a century or more. It has seen storms come and go, rivers change course, forests grow and burn. It is a living monument to the power of evolution to create the extraordinary. And in the north, in the twilight of the era, stalks the tyrant lizard king. Tyrannosaurus Rex. It is 12 meters long and weighs 8 tons. It is not just a brute, it is a sensory genius. Its binocular vision is better than a hawk's. Its sense of smell is unparalleled. It can crush bone with a bite force of 35,000 newtons. It faces down a triceratops, a three-horned tank with a bony frill. An ankylosaurus crouches nearby, a living fortress covered in armor plates and wielding a bone-crushing tail club. The T-Rex is the culmination of 165 million years of predatory evolution. Its brain, while small relative to its body size, is highly developed in the regions governing vision and smell. It can detect the scent of a carcass from kilometers away. Its eyesight is so acute it can detect motion at great distances, tracking prey through dense vegetation. Its legs are powerfully muscled, capable of bursts of speed approaching 30 kilometers per hour, more than enough to run down a fleeing hadrosaur. And those jaws, those terrible bone-crushing jaws, they are the most powerful bite of any terrestrial animal that has ever lived. They can puncture through bone, muscle, and hide with ease, delivering a killing blow that is mercifully swift. But the T-Rex is not invincible. The Triceratops it faces is a formidable opponent. Those horns, each over a meter long, are lethal weapons. The frill protects its neck. It lowers its head, snorting, pawing the ground. The two titans circle each other in the clearing. The outcome is uncertain. Both are products of an evolutionary arms race that has been escalating for millions of years. Both are perfectly adapted to this moment, this place, this world. The sun sets on this Cretaceous world, casting long shadows. The amber light catches the dust motes. The air cools. The cicadas sing. It feels eternal. It feels like it will last forever. There is no hint in the sky of the rock that is hurtling through the dark vacuum of space, aiming for the Yucatan Peninsula. There is only the low vibration of the earth, the distant thunder of footsteps, and the breathing of a living planet at its peak. So, here we stand. We look back across the abyss of time at this 165 million-year dynasty. And the question returns, sharper now, more insistent. It is not just a question of how they survived. Mechanics are easy to explain. Lungs, legs, metabolism. These are parts of an engine. The real question is why. Why did this specific dominance last so remarkably, improbably long? In the history of complex life on Earth, nothing else compares. Mammals have been dominant for perhaps 66 million years, less than half the time of the dinosaur reign. We humans have been civilized for mere thousands. Dinosaurs held the throne through shifting continents, through fluctuating atmospheres, through changing climates. They did not just endure. They thrived. They reinvented themselves over and over again. Consider the magnitude of this achievement. 165 million years is not merely a long time. It is an almost infinite stretch of geological patience. It is longer than the entire span from the first flowering plant to the present day. It is 3 times longer than the entire age of mammals. It encompasses the complete breakup of Pangea, the opening of the Atlantic Ocean, the rise and fall of entire mountain ranges. Through all of this, through cosmic catastrophe and climatic chaos, the dinosaurs remained the architects of their world. The hidden truth of their reign is not a single secret key. It is a perfect storm, a convergence of factors that no single animal group has managed to replicate since. It is a puzzle with 3 distinct pieces, locking together to form an unbreakable picture of power. First, we must ask, was it biology alone? Was the combination of the avian-style air sac system, the rapid growth rates, and the efficient upright gait simply a winning hand that couldn't be beaten? Did they simply out-engineer every other living thing? Their bodies allowed them to grow to sizes that made them invulnerable to predation. Their reproduction, laying clutches of eggs rather than carrying a single fetus for months, allowed populations to bounce back from disaster with terrifying speed. A mammal mother might lose both herself and her offspring in a drought. A dinosaur mother could leave 20 eggs in the sand and move on, ensuring the next generation's survival. Think about the flexibility this gave them. A single species of dinosaur could produce dozens of offspring in a single season, hedging its bets against predation, disease, and environmental catastrophe. The investment was distributed, the risk was spread, and when conditions improved, the population could explode in a matter of years. This reproductive strategy, combined with their metabolic efficiency, created a biological machine that was almost impossible to disrupt permanently. Their range of body sizes was another advantage that cannot be overstated. From the tiny, bird-like Microraptor to the colossal Patagoteton, dinosaurs occupied every ecological niche simultaneously. They were the mice and the elephants. They were the sparrows and the eagles. No other group of animals has ever achieved such diversity within a single lineage. This meant that when one end of the spectrum suffered, when climate change favored small, agile animals over giants or vice versa, there were always dinosaurs positioned to thrive? Or, secondly, was it the timing? Was their reign born not of their own merit, but of the catastrophic misfortune of their rivals? The dinosaurs were the beneficiaries of two of the greatest mass extinctions in history. The Great Dying cleared the board for their ancestors. The end Triassic extinction wiped out their direct competitors, the Crurotarsans. Did they win the lottery twice? Were they simply the lucky inheritors of an empty mansion, wandering into a world that had been scrubbed clean of anyone who could challenge them? There is something uncomfortable about this possibility. It suggests that dominance is not earned, but inherited. That success is not a product of superiority, but of survival. That the dinosaurs were not chosen by evolution for greatness. They were simply standing in the right place when the meteor struck everyone else. They were the understudies who became the stars when the leads failed to show up. But perhaps this discomfort reveals a deeper truth. Perhaps survival is the ultimate evolutionary achievement. Perhaps being adaptable enough, generalist enough, resilient enough to endure when specialists perish. Perhaps that is superiority. The dinosaurs did not need to be the fastest or the strongest. They needed to be the ones still breathing when the smoke cleared. And they were, twice. And yet, even this does not fully answer the question, because luck alone cannot sustain a dynasty for 165 million years. Luck gets you through the door. Biology keeps you in the room. But something else, something harder to quantify, allows you to renovate the entire building and make it your own. And finally, or perhaps most fascinatingly, could they have gone on even longer? If not for a single random object falling from the sky 66 million years ago, would we be here at all? There is no biological rule that says their reign had to end. They were not in decline. They were not evolutionary dead ends. They were innovating right up until the moment the sky caught fire. Without the asteroid, would the Earth today still be a planet of scales and feathers with mammals remaining forever in the dark, scurrying underfoot? This is the question that haunts paleontology. The fossil record from the late Cretaceous shows no signs of a dying dynasty. New species were still emerging. Ecosystems were complex and stable. Tyrannosaurs had only recently evolved their most advanced forms. The hadrosaurs and ceratopsians were flourishing in the northern continents. Intelligence, true problem-solving intelligence, was beginning to appear in the troodontids. We small feathered dinosaurs with brain-to-body mass ratios approaching those of modern birds. What if the asteroid had missed by a mere 20 minutes? What if the Earth's rotation had carried the Yucatan Peninsula just out of the impact zone, and the rock had plunged into the deep Pacific instead, where the ocean could absorb the blow? The dinosaurs would have endured. They would have continued evolving. And in another 65 million years, our 65 million years, what would they have become? Would intelligence have eventually emerged in a reptilian mind instead of a mammalian one? Would there be cities today built not by apes, but by the descendants of Troodon or Stenonychosaurus? Would philosophy and art and science have arisen under a scaled brow instead of a furred one? These are unanswerable questions, but they are worth asking, because they force us to confront the fragility of our own existence. We are not the inevitable end point of evolution. We are the beneficiaries of a cosmic accident. We are here because they are not. The hidden truth, then, is this. The dinosaurs ruled for 165 million years because they were biologically exceptional, historically fortunate, and evolutionarily open-ended. They were the right animals, in the right place, at the right time, with the right capacity to change. And when that capacity was finally tested by something beyond adaptation, by a rock from space carrying the kinetic energy of 1 billion suns, they failed not because they were weak, but because nothing could have survived. Their reign was not a story of inevitability. It was a story of contingency, biology, and deep time converging into something unrepeatable. And that, perhaps, is the most profound truth of all. But here is where the story becomes truly extraordinary. We often imagine the dinosaurs as inevitable. We see T-Rex and Brachiosaurus and assume that from the moment the first reptile crawled onto land, evolution was marching toward them. We assume they were superior from day one, that they took the crown by force because they were simply better. This is false. New research suggests that the dinosaurs' dominance was not inevitable. In fact, for the first 20 to 30 million years of their existence, they were the underdogs. They were minor players. In the ecosystems of the Triassic, they were outnumbered and outgunned by the Crurotarsans, the Dicynodonts, and the Rhynchosaurs. If you were a time traveler standing in a Triassic forest and you had to bet on which group would rule the future, you would not have bet on the dinosaurs. You would have bet on the crocodile-line archosaurs. They were bigger, they were more diverse, they occupied the top predator roles and the top herbivore roles. Let us examine the evidence. In 2017, a comprehensive study published in the journal Proceedings of the National Academy of Sciences analyzed thousands of fossil sites from the Triassic period. The researchers counted bones, they measured diversity, they reconstructed ancient food webs. The conclusion was stark. For the first 30 million years of their evolutionary history, dinosaurs made up less than 15% of the fauna in most ecosystems. They were not the dominant predators. They were not the dominant herbivores. They were marginal opportunists, filling the gaps left by the more successful groups. Consider the late Triassic predator hierarchy. At the top stood creatures like Saurosuchus, a massive crocodile-line archosaur that reached lengths of 7 meters and weighed over 800 kilograms. It had a skull nearly a meter long, filled with serrated teeth. It walked on 4 legs but could rear up to attack. It was the apex predator, unchallenged. Below it were the Rauisuchians, armored, powerful hunters that dominated the mid-tier predator roles. The early dinosaurs? They were scavengers. They hunted insects and small vertebrates. They stayed in the undergrowth. They were afraid. And it wasn't just the predators. The herbivore niches were locked up too. The Dicynodonts, strange, tusked reptiles that look like nothing alive today, grazed in vast herds. The Rhynchosaurs, with their barrel-shaped bodies and powerful beaks, stripped vegetation from the cycads. The Etosaurs, covered head to tail in bony armor, were the tanks of the Triassic. Where did that leave the early dinosaurs? Nowhere. They were evolutionary afterthoughts. But here is the twist. Here is the secret that changes everything. The dinosaurs had one advantage that none of their rivals possessed. It was not strength, it was not size, it was not intelligence, it was patience. Or rather, it was the capacity to endure. While the Crurotarsans were specialists, finely tuned biological machines optimized for the hot, dry Triassic, the dinosaurs were generalists. They could eat a variety of foods. They could tolerate a range of temperatures. They could survive in marginal environments. They were not the best at anything, but they were good enough at everything. And when the world changed, when the volcanoes erupted and the climate collapsed at the Triassic-Jurassic boundary, the specialists died. The generalists endured. The Crurotarsans, so perfectly adapted to the world that was, could not adapt to the world that came next. The dinosaurs, simply by virtue of being less specialized, survived. The shocking twist of deep time is this. Dinosaurs became rulers not through their own immediate superiority, but because every other group catastrophically failed. They won by default. They were the survivors of a game of Russian roulette played on a planetary scale. As one academic consensus famously puts it, dinosaurs were not the obvious winners, they were simply the last ones standing. This revelation forces us to reconsider everything. Success in evolution is not about being the strongest or the fastest. It is about being the one still breathing when the dust settles. The dinosaurs inherited the Earth not because they conquered it, but because everyone else vacated it. And once they stepped through that door, they locked it behind them. For 165 million years, no other group would ever challenge their supremacy again. Not because they were invincible, but because the competition was extinct. This is the hidden truth. This is the secret we almost missed. The reign of the dinosaurs was not a story of triumph. It was a story of survival. And perhaps that is the most powerful lesson of all. If this story is carrying you somewhere peaceful, feel free to close your eyes. The narration will guide you. Let us drift back to the beginning of the struggle. The stage is late Triassic Pangea. The curtain rises on a world that does not belong to the dinosaurs. It belongs to the bizarre, the armored, and the heavy. The ecosystem is dominated by the Cretaceous, the crocodile ankle reptiles. These are not the aquatic crocodiles we know today. These are terrestrial monsters. Creatures like Postosuchus prowl the land. It is a 4-meter-long nightmare. A walking fortress of muscle and teeth that moves on 4 legs but can rear up on 2 to strike. It is the apex predator. It fears nothing. Alongside it are the Dinosaurs, heavily armored herbivores that look like armadillos covered in spikes. And the Phytosaurs, massive river predators that resemble modern crocodiles but with nostrils perched high on their foreheads like periscopes. In this world, the early dinosaurs are pushed to the margins. They are small, generalist omnivores and carnivores. They scavenge, they hunt small game, they stay out of the way. Picture this hierarchy more clearly. The Cretaceans have evolved into an astonishing array of forms. Saurosuchus, reaching 7 meters in length, lies in ambush near waterholes, its jaws powerful enough to crush the skull of any herbivore foolish enough to drink at the wrong time. The Rauisuchians, including Fasolosuchus from South America, are the wolves of the Triassic, pack coordinators that can bring down prey twice their size through strategic hunting. They have forward-facing eyes for depth perception, muscular tails for balance, and rows of teeth designed for maximum tissue damage. The herbivorous niche is equally crowded. The Dicynodonts, survivors of the Permian extinction, have returned in force. Placerias, a pig-sized herbivore with twin tusks, roams in massive herds across the floodplains of what will one day be Arizona. They are like the buffalo of the Triassic, stripping vegetation down to the roots. The Rhynchosaurs, with their curved beaks and grinding tooth plates, specialize in tough seed ferns. And above them all, the Dinosaurs, quadrupedal tanks like Desmatosuchus, walk slowly and fearlessly, their bodies entirely encased in interlocking bony plates. Where do the dinosaurs fit? They hide. The early forms, like Eoraptor, the Herrerasaurus and Staurikosaurus, are slender, fast, and cautious. They are opportunists. They hunt at dawn and dusk when the larger predators are less active. They eat insects, small reptiles, eggs. They scavenge carcasses after the Cretaceans have had their fill. They are evolutionary experiments, testing different body plans, different strategies. Most will fail. A few will endure. 20 million years after their first appearance, dinosaurs are still a minority. They constitute perhaps 10 to 20% of the animals in any given environment. They are successful, yes, but they are not dominant. They are waiting in the wings of history. Then, around 232 million years ago, the skies opened. The Carnian pluvial episode began. For 2 million years, the rains fell. The arid world turned wet. The seed ferns that the Cretaceans relied on began to die out, replaced by conifers and lush vegetation. The ecosystem was reshuffled. The dinosaurs, adaptable and mobile, began to expand their numbers, but they were still checked by their rivals. They were waiting for the door to open. This waiting period is critical. During these 20 million years, the dinosaurs are refining their design. Their upright posture is becoming more efficient. Their respiratory systems are becoming more effective. Their growth strategies are being tested against harsh environments. They are learning, in the evolutionary sense, how to survive catastrophe. They do not know it yet, but they are being forged in the fire of competition into something resilient, something flexible, something that will outlast empires. The door did not just open, it was blown off its hinges. 201 million years ago, the Central Atlantic magmatic province, Camp, ignited. It was a volcanic event of apocalyptic proportions. Fissures opened in the crust as Pangea began to unzip. Magma poured out, covering millions of square kilometers. But it wasn't the lava that killed, it was the gas. Carbon dioxide levels tripled. Methane, released from the warming seafloors, spiked the atmosphere. Global temperatures rose by 3 to 4 degrees Celsius in under 10,000 years, a blistering heat shock. The oceans stagnated and turned acidic. On land, the change was too fast for the specialized Cretaceans. Their large, heavy bodies required stability. They could not cope with the heat stress. They could not find food as the plant life collapsed. The camp eruptions were not a single event. They occurred in pulses over roughly 600,000 years. Imagine standing on the edge of Pangea as it splits. The ground shakes. Fissures hundreds of kilometers long crack open, glowing red from within. Rivers of lava flow like water, burning everything in their path. The sky turns black with ash. The sun becomes a dim red disk barely visible through the haze. Acid rain falls, stripping leaves from trees, poisoning rivers. The air itself becomes toxic, thick with sulfur dioxide. The Cretaceans, those magnificent rulers of the Triassic, are caught in an evolutionary trap. They are specialists. Their bodies are optimized for the hot, dry world of Pangea's interior. Their metabolism is calibrated to specific temperature ranges. Their food sources are specific plants and prey animals. When the climate shifts, when the heat becomes unbearable even for heat-adapted animals, when the plants die and are replaced by opportunistic species, they cannot adjust quickly enough. Evolution works on geological timescales, but this catastrophe is happening in mere thousands of years. One by one, the ruling families of the Triassic flickered and went out. The phytosaurs vanished. The etosaurs died. The Rauisuchians, the top predators, disappeared. 76% of all species on Earth were extinguished. But amidst the ash and the heat, the dinosaurs endured. Their efficient bird-like lungs allowed them to extract oxygen from the superheated, stagnant air. Their upright, mobile bodies allowed them to migrate in search of surviving pockets of vegetation. Their rapid growth rates allowed populations to rebound quickly. And so, 201 million years ago, the world was handed to them. The rivals were gone. The throne was empty. The boundary layer between the Triassic and Jurassic is marked by a distinct change in the fossil record. On below the line, diversity, chaos, the bones of many different groups jumbled together. Above the line, simplicity. Dinosaur fossils dominate. Small ancestral crocodiles huddle near the water. Early mammals remain in the shadows. But the giants, the rulers, the dinosaurs, they are everywhere. They have inherited a broken world, yes, but it is theirs to rebuild. And rebuild it they will. 50 million years after the end Triassic extinction, the world had transformed. The dinosaurs did not just step into the empty niches left by their rivals, they exploded into them. They radiated into forms that defied logic. This was the Jurassic, the golden age of gigantism. With no competition, the sauropods began their ascent to the heavens. The lush, high canopy forests of the Jurassic provided an endless buffet of energy. In an atmosphere rich with rising oxygen levels, these animals grew to sizes that seem mechanically impossible. Brachiosaurus, towering over the tree line. Diplodocus, stretching the length of 3 buses. Why so big? Size was safety. A fully grown sauropod had no natural predators. It was a walking fortress. Gigantism was also a byproduct of their biology. Their bird-like lungs and hollow air-filled bones reduced their weight, allowing them to grow larger without collapsing under their own mass. But let us linger on this gigantism for a moment, because it is one of the most extraordinary achievements in evolutionary history. A fully grown Brachiosaurus weighed approximately 50 tons, the weight of 10 African elephants. Its neck alone was 9 meters long, composed of 13 elongated vertebrae. The blood pressure required to pump blood to its brain was immense, perhaps 250 millimeters of mercury, 3 times that of a human. Some paleontologists theorize that sauropods may have had multiple hearts, or heart-like pumping stations along the neck to assist circulation. The mechanics of their existence push the boundaries of what biology can achieve, and they were not alone. The Morrison Formation in the western United States, dating to 155 to 148 million years ago, preserves a snapshot of this world. Here, Apatosaurus, Camarasaurus, and Diplodocus grazed side by side, each specializing in different feeding heights to minimize competition. The forests rang with their calls, low-frequency rumbles that traveled for kilometers, felt as much as heard. Young sauropods stayed with their herds for protection, growing rapidly but remaining vulnerable for years. The predators followed suit. Allosaurus became the terror of the Jurassic plains, hunting in loose associations to take down larger prey. Ceratosaurus, with its nasal horn, prowled the swamps. And in the undergrowth, a quiet revolution was happening. Around 150 million years ago, small feathered theropods like Archaeopteryx began to experiment with flight. They were not birds yet, but they were the draft sketches. The separation between earth and sky was beginning to blur. Allosaurus was a precision hunter. At 9 meters long and weighing up to 2 tons, it was built for short bursts of speed and devastating ambush attacks. Its skull was lightly built, with large openings to reduce weight, but the jaws were capable of opening extraordinarily wide, over 90 degrees. The strategy was not to bite and hold like a tyrannosaur, but to strike like a hatchet, using the weight of the skull and the serrated teeth to deliver slashing wounds. A pack of Allosaurus could bring down a young sauropod by inflicting multiple wounds and waiting for blood loss to do the rest. And in the canopy above, something new was stirring. Archaeopteryx, discovered in the limestone quarries of Bavaria, is one of the most famous fossils in the world. It had the teeth and claws and long bony tail of a theropod dinosaur, but it also had asymmetrical flight feathers on its wings and tail, unmistakable adaptations for powered flight. It could fly, but not well. It was clumsy, experimental, but it was the beginning. The dinosaurs were not content to rule the land, they were reaching for the sky. As the Jurassic gave way to the Cretaceous, the planet underwent another metamorphosis. About 130 million years ago, a new kind of life appeared: flowering plants. The angiosperms. Suddenly, the world was awash in color. Fruits, nuts, and flowers provided dense, high-energy food sources. This triggered a new explosion of dinosaur evolution. The herbivorous dinosaurs changed to exploit this new food. The sauropods declined in the north, replaced by the great chewers, the hadrosaurs or duck-billed dinosaurs with their batteries of thousands of grinding teeth. And the ceratopsians, the horned dinosaurs like Triceratops, evolved shearing beaks to slice through tough vegetation. The ecosystems became more complex, more crowded, more vibrant. The flowering plant revolution cannot be overstated. Before the angiosperms, the world was dominated by gymnosperms, conifers, cycads, ginkgos, plants that reproduced slowly and grew in limited forms. The angiosperms changed the rules. They reproduced rapidly, spread quickly, and offered unprecedented diversity. Within 20 million years, they had colonized nearly every terrestrial environment. They brought with them a riot of color and scent, attracting insects for pollination. Bees, butterflies, and beetles diversified alongside them. The world became richer, denser, more interconnected. The hadrosaurs were among the first to capitalize on this bounty. Creatures like Edmontosaurus and Parasaurolophus had dental batteries, interlocking rows of hundreds of teeth that formed grinding surfaces capable of processing the toughest vegetation. They moved in massive herds, migrating seasonally across the northern continents. Their hollow crests, particularly prominent in Parasaurolophus, functioned as resonating chambers, producing low-frequency calls that coordinated herd movements and warned of predators. But the soundscape of the late Cretaceous was filled with these haunting musical tones echoing across the plains. In the oceans, the western interior seaway reached its peak 97 million years ago. It was 800 kilometers wide, splitting North America into Laramidia in the west and Appalachia in the east. It was a dangerous, shallow sea ruled by marine reptiles, giant mosasaurs and long-necked plesiosaurs, while pterosaurs with wingspans of 10 meters cast shadows on the waves. And on land, in the last 20 million years of the Cretaceous, the tyrannosaurs ascended. They were the culmination of carnivorous evolution, smart, fast, and armed with bone-crushing power. In the Hell Creek Formation, 67 million years ago, Tyrannosaurus Rex and Triceratops engaged in an evolutionary arms race that would become legendary. The western interior seaway was a world within a world. Tylosaurus, a mosasaur reaching 14 meters in length, ruled these waters with serrated teeth and powerful swimming muscles. Elasmosaurus, with its impossibly long neck comprising 72 vertebrae, hunted fish in the murky depths. Above, Pteranodon glided on 7-meter wingspans, diving to snatch fish from the surface. The seaway was a highway of nutrients and life, connecting the Arctic Ocean to the Gulf of Mexico, creating unique ecosystems on either shore. And then there were the tyrannosaurs. For 20 million years, they refined the art of predation. Tyrannosaurus Rex was not the first tyrannosaurid, but it was the ultimate expression of the lineage. Its bite force, measured at 35,000 to 57,000 newtons, could crush bone to extract the calorie-rich marrow inside. Its teeth were thick, conical, designed not to slice, but to grip and pulverize. It had binocular vision superior to a hawk's, capable of spotting prey at great distances. And its sense of smell was extraordinary, with olfactory bulbs larger than its optic lobes. It was a sensory genius wrapped in 8 tons of muscle and bone. How did they keep this up for 165 million years? The answer lies under the skin. The biology of dinosaurs was a masterpiece of adaptation. Central to their success was the avian air sac respiratory system. Unlike mammal lungs, which are flexible bags that inflate and deflate, dinosaur lungs were rigid. Air was pumped through them by a series of bellows-like sacs throughout the body. This meant fresh oxygen flowed over the lung tissue constantly, both when breathing in and when breathing out. It was a supercharged engine. Let us examine this respiratory miracle more closely. The air sacs extended throughout the body cavity and even into the hollow spaces within the bones themselves, a feature called pneumatization. When a dinosaur inhaled, fresh air filled the posterior air sacs. When it exhaled, that air was pushed through the lungs, where oxygen was extracted. Simultaneously, a new breath was filling the posterior sacs. The result? Continuous unidirectional airflow, no mixing of stale and fresh air, maximum oxygen extraction. This system is still used by birds today, which is why a bar-headed goose can fly over Mount Everest, breathing air so thin it would incapacitate a mammal. For dinosaurs living in the low-oxygen Triassic, this was survival. For dinosaurs in the oxygen-rich Cretaceous, this was power. It allowed them to sustain high levels of activity. It allowed sauropods to pump oxygen through impossibly long necks. It allowed theropods to chase prey without tiring. It was the biological foundation of their dominance. Then there is the question of blood. In 1968, paleontologist Robert Bakker published a paper titled The Superiority of Dinosaurs, arguing that they were endothermic, warm-blooded. The evidence has mounted since. We find bone growth rings that suggest rapid, sustained growth, unlike the slow, stop-start growth of cold-blooded reptiles. We find feathers, insulation on even primitive dinosaurs, suggesting they needed to trap body heat. This high metabolism allowed them to be active, alert, and dominant in all climates, from the equatorial swamps to the frozen polar forests. The evidence for warm-bloodedness, or at least mesothermy, is now overwhelming. Studies of bone histology show fibrolamellar bone tissue, indicative of rapid, continuous growth. Isotopic analysis of dinosaur bones suggests body temperatures significantly higher than ambient temperatures. The presence of complex social behaviors, pack hunting, parental care, migration, implies energy-intensive lifestyles incompatible with pure ectothermy. And then there is the simple logic of size. A cold-blooded animal the size of a Tyrannosaurus would take hours to warm up in the morning sun. It would be sluggish, vulnerable. But a warm-blooded or mesothermic Rex could hunt at dawn, at dusk, or even at night. Their reproduction was another key. Dinosaurs laid eggs. This might seem primitive compared to live birth, but it was a logistical advantage. A pregnant mammal is vulnerable. She carries her investment with her. A dinosaur could lay a clutch of 20 eggs and remain mobile. If disaster struck, the population could rebound explosively. They also spanned an incredible range of body sizes, from the 30-centimeter Microraptor to the 30-meter Argentinosaurus, occupying every niche from insect eater to tree toppler. The egg-laying strategy also allowed for something mammals cannot achieve: massive clutches. A Maiasaura could lay 30 to 40 eggs in a single nesting season. Even if only a fraction survived, the population growth potential was enormous. Fossil sites like Egg Mountain in Montana reveal communal nesting grounds where hundreds of individuals nested together, providing mutual protection and potentially cooperative parental care. The juveniles grew rapidly, reaching near adult size within a decade. This reproductive efficiency, combined with metabolic adaptability, made dinosaurs nearly impossible to eliminate through anything short of global catastrophe. But nothing lasts forever. In the final millennia of the Cretaceous, the world began to strain. The Deccan traps in present-day India began to erupt around 66 million years ago, pouring poison into the atmosphere and stressing global ecosystems. Some paleontologists argue that dinosaur diversity was already in decline. Others, like Jack Horner and Philip Curry, look at the Hell Creek fossils and see a thriving, robust ecosystem right up until the end. The debate about pre-impact decline is contentious. The Deccan traps were releasing massive amounts of volcanic gas, sulfur dioxide, carbon dioxide, chlorine, creating acid rain and greenhouse warming pulses. Each eruptive phase would have caused short-term cooling from sulfur aerosols, followed by long-term warming from CO2. This climatic instability may have stressed dinosaur populations. Some studies suggest a decline in species diversity in the final million years. Others point out that the fossil record is inherently incomplete, and what appears as decline may simply be gaps in preservation. But the Hell Creek Formation tells a different story. Here, in the Badlands of Montana and the Dakotas, we find the last snapshots of the dinosaur world. The Tyrannosaurus Rex at its peak. Triceratops herds numbering in the hundreds. Ankylosaurus, Edmontosaurus, Pachycephalosaurus, all thriving. The ecosystem was complex, layered, functional. There were small mammals, yes, but they were still in the shadows, still nocturnal, still waiting. The dinosaurs showed no signs of surrendering their throne. Then the clock ran out. 66.043 million years ago, a rock, an asteroid, roughly 12 kilometers wide. It was traveling at 20 kilometers per second. It slammed into the shallow waters of the Yucatan Peninsula in modern-day Mexico. The energy released was equivalent to approximately 10 billion atomic bombs of the Hiroshima type. The impact punched a hole in the atmosphere. It sent a plume of vaporized rock and seawater halfway to the moon. Within 24 hours, bits of this ejector re-entered the atmosphere, heating the air to the temperature of a pizza oven. Forests across the globe spontaneously ignited. A global firestorm raged. Then came the dark. The dust and soot blocked the sun. A nuclear winter descended. Photosynthesis stopped. The food web collapsed from the bottom up. 76% of all species on Earth perished. The dinosaurs, those magnificent, adaptable, enduring masters of the planet, were erased. Their 165 million year reign ended not with a whimper, but with a bang. A sudden, violent interruption to a story that was still being written. Let us linger on that final day. The morning of the impact was probably ordinary. Herds of hadrosaurs grazing in the floodplains, a tyrannosaur sleeping off a meal in the shade, pterosaurs fishing in the shallow sea. Then, at approximately 6 p.m. local time, the sky lit up. The asteroid hit the Yucatan at a shallow angle, approximately 60 degrees from horizontal. The energy of the impact was concentrated forward, evaporizing the rock and creating a fireball 100 kilometers wide. The shockwave flattened forests for 1,000 kilometers in every direction. Earthquakes of magnitude 10 or greater shook the entire planet. Tsunamis hundreds of meters high radiated outward, scouring coastlines. But it was what happened next that sealed the fate of the dinosaurs. The impact ejected trillions of tons of rock, dust, and sulfate aerosols into the stratosphere. Within hours, this debris began to spread globally. The bits of molten ejecta re-entered the atmosphere worldwide, creating a heat pulse that raised global temperatures by 10 degrees Celsius for several hours. The forests, already stressed by the shockwave, ignited. Soot from the burning forests mixed with the impact dust, creating a black shroud that blocked 99% of sunlight. Photosynthesis halted. Temperatures plummeted. The planet froze in darkness. The herbivores died first. Without plants, they starved within weeks. The carnivores followed once the corpses were consumed. Small animals, those that could burrow, that could hibernate, that could survive on seeds and detritus, endured. The mammals, hiding in burrows, made it through. The birds, descendants of small theropods, survived in small numbers. But the great dinosaurs, those titans of the Mesozoic, could not adapt to a world without food, without warmth, without light. Within months, they were gone. Within years, the Earth was silent. The age of reptiles was over. The age of mammals was about to begin. But let us dream for a moment. Let us unwrite the catastrophe. Imagine that the asteroid arrived 20 minutes later. The Earth has rotated slightly. The rock misses the shallow continental shelf and plunges into the deep waters of the Pacific or Atlantic. The ocean absorbs the blow. There are tsunamis, yes, there is destruction. But there is no global firestorm. There is no nuclear winter. The sun rises the next day, and the dinosaurs are still there. Close your eyes. Feel the rotation of the Earth beneath you. 20 minutes. A fraction of a degree. The difference between annihilation and continuation. The asteroid streaks through the atmosphere, a ball of stone and metal traveling at 20 kilometers per second, trailing fire across the sky. But the target has moved. Instead of striking the shallow carbonate platform of the Yucatan, it plunges into the abyssal plain of the Pacific Ocean, where the water is 5 kilometers deep and the ocean floor is ancient, cold basalt. The impact is still catastrophic. A column of water vapor and steam erupts into the stratosphere. Mega tsunamis ripple outward, devastating coastlines across the Pacific Rim. Earthquakes shake the Ring of Fire, but the energy dissipates. The water absorbs what the thin continental shelf could not. There is no vaporized limestone releasing billions of tons of sulfur dioxide. There is no fine dust to blacken the sky for years. The forests do not ignite. The sun, though dimmed for weeks by the steam and ash, returns. Photosynthesis resumes. The food chain bends but does not break, and the dinosaurs endure. The herbivores along the coasts are devastated. Entire populations are swept away by the tsunamis, but inland, in the river valleys and forests, the survivors wait out the chaos. Within a year, green shoots return. Within a decade, the herds have recovered. The reign continues. What if they had continued? What if their reign had extended for another 65 million years, all the way to the present day? Let us walk through this alternate Earth. It is a world both alien and familiar. The continents are in their modern positions, but the life upon them is unrecognizable. Let us begin our journey in the far north. The Arctic Circle, 2026 CE, in a timeline that never was. The land here is tundra, vast and treeless, is swept by winds that taste of ice and stone. But it is not empty. The ice ages still came and went, carving the landscapes with glaciers that advanced and retreated like the slow breath of the planet. But here, woolly mammoths never evolved. The mammals remain small, hidden, nocturnal. Instead, the megafauna of the north are descendants of the ceratopsians. The ice ages still came and went, carving the landscapes, but here, woolly mammoths never evolved. Instead, the tundra of the north is walked by shaggy, insulated dinosaurs. Herds of woolly ceratopsians use their massive beaks to shovel snow from the lichen. They are followed by troodontids with thick plumage, intelligent pack hunters that coordinate their attacks with frightening precision. Watch them move across the snow. These woolly ceratopsians, evolved from the Triceratops lineage, are covered in thick, shaggy fur-like filaments, proto-feathers that trap heat against their massive bodies. Their frills have evolved into snow scoops, broad and flat, used to push aside the powder to reach the lichen and moss beneath. They move in herds of 50 or more, their breath forming clouds in the frigid air. Their calls are low, resonant, felt through the permafrost. In the summer, when the sun never sets, they migrate north to the coastal plains where the brief explosion of plant growth sustains them. In winter, they retreat south, following ancient routes carved by their ancestors over millions of years. And they are hunted. The troodontids have become the wolves of this world. They are small, no larger than a human, but their brains are proportionally enormous. They coordinate, they plan, they communicate with a complex language of chirps, whistles, and body postures. A hunting pack of 12 moves silently through the snow, their feathered bodies perfectly camouflaged against the white landscape. They have learned to separate the young from the herd, to work in relays, wearing down their prey over hours or even days. They do not have the bite force to kill a woolly ceratopsian quickly. But they have intelligence, they have patience, and they have time. Let us drift south now, following the migration routes, crossing continents that have drifted into their modern configurations but remain unrecognizable. The great ice sheets that once covered Canada and northern Europe have melted as the climate warmed in the Holocene of this alternate timeline. But without human agriculture, without deforestation, the world is greener, lusher, wetter than the Earth we know. In the warm, lush tropics of South America and Africa, the sauropods have pushed the limits of biology even further. Meet Neosaurus magnus. It is a titan of the alternate modern era. It weighs over 100 tons. Its neck is so long it grazes the clouds. It moves through the rainforests like a living ship, ecosystems of birds and insects living entirely upon its massive back, never touching the ground. The Amazon basin in this world is not a river system punctuated by cleared land and roads. It is an unbroken cathedral of green stretching from the Andes to the Atlantic, a forest so dense that the floor is in perpetual twilight. And through this cathedral, moving with the slow inevitability of geological time, walks Neosaurus magnus. It is the descendant of the Tyrannosaurs, the culmination of 230 million years of sauropod evolution. Its body is an evolutionary masterpiece. Its legs are pillars of bone and muscle, each footstep compressing the soil, leaving depressions that fill with water and become microhabitats for frogs and insects. Its neck rises impossibly high, 40 meters into the canopy, where it feeds on the highest leaves, browsing at altitudes where no other creature can compete. Its skin is thick, grey, wrinkled like ancient leather, but along its spine and flanks grow patches of moss and lichen, watered by the humidity and fertilized by the creature's own shed skin cells. Small birds nest in the folds of its hide. Insects burrow into the moss. It is not just an animal. It is a walking biome, a mobile island of life moving slowly through the endless green. It breathes slowly, deeply. Each inhalation draws in hundreds of liters of humid, oxygen-rich air, pumped through its efficient avian respiratory system. It feeds continuously, stripping entire branches with its peg-like teeth, swallowing them whole, letting its massive gut ferment the cellulose over days. It produces low-frequency calls that travel for tens of kilometers, communicating with others of its kind scattered across the vast forest. It is not alone. There are dozens of Neosaurus in the Amazon. They are not social, but they are aware of each other, coordinating their movements to avoid depleting any one area of foliage. And in the shadows beneath, in the filtered green light of the understory, other dinosaurs move. Small herbivores, descendants of the ornithopods, browse on ferns and fungi. They are quick, nervous, always watching for predators. Because the theropods have not gone extinct, they have diversified. The theropods, the meat-eaters, have evolved too. The tyranny of the T-Rex eventually gave way to agility and intellect. In the savannas of an alternate Africa, isolated from the rest of the world, we find Veloci sapiens. These are descendants of the dromaeosaurs. They stand upright, freeing their forelimbs, their hands for manipulation. They have large, complex brains. They use tools. They communicate in a language of clicks and whistles. They do not build cities of stone, but they weave intricate nests in the canopy. Are complex societies hidden in the leaves. Let us observe them more closely. Veloci sapiens stands approximately 1.5 meters tall when upright, though it can still drop to all fours for speed. Its forelimbs, arms now, truly, have evolved elongated, dexterous fingers tipped with retractable claws. It has opposable digits. It can grip. It can manipulate. Its skull is graceful, bird-like, with large, forward-facing eyes that provide excellent binocular vision. Its brain case is enlarged, bulging at the back, housing a cerebrum that approaches the complexity of a chimpanzee's. It uses tools. Simple ones, yes, but tools nonetheless. Sharpened sticks to dig termites from mounds. Stones to crack nuts. Thorns plucked from acacia branches to extract grubs from dead wood. It has been observed by no one, of course, because there are no humans here, teaching these techniques to its young, a cultural transmission of knowledge that spans generations. Its social structure is complex. Groups of 20 to 30 individuals live together in extended family units, nesting in the upper canopy where they are safe from larger ground predators. They build platforms of woven vines and branches, structures that can last for years, expanded and maintained by successive generations. They communicate constantly, chirps for location, whistles for danger, clicks for coordination during hunts. Some researchers in our timeline have theorized that if dinosaurs had survived, our intelligence might have emerged. Here, in this dream, it has. Not human intelligence, Not consciousness as we understand it, but something parallel, something alien, a reptilian mind that sees the world differently, thinks differently, solves problems in ways we can never know. They do not have language as we define it. They do not tell stories or contemplate mortality. But they remember, they plan, they anticipate. They are aware of themselves as individuals distinct from the group. They are, in their own way, sapient. And if given another 65 million years, who can say what they might become? Let us drift now across the Atlantic to the continent that would have been Europe. The Mediterranean has not dried and refilled as it did in our timeline. Instead, it has remained a warm, shallow sea, its waters teeming with marine reptiles. Mosasaurs never went extinct here. They evolved, diversified, filled every niche from shallow water ambush predators to deep-diving squid hunters. The largest, Thalassotyrannus, reaches 25 meters in length, hunting the pods of fish-like dinosaurs that evolved from semi-aquatic ornithopods. In North America, the great inland seas never fully drained. They remain warm, shallow waterways teeming with life. Here, bird-line dinosaurs have evolved to fill the niches of whales and dolphins. Flightless, streamlined divers patrol the reefs. The air is filled not with the sound of mammals, but with the calls of pterosaurs that have become as large as gliders, drifting on the thermals for days without landing. The Western Interior Seaway, which in our timeline drained as the Rockies rose and the climate dried, has persisted in this alternate world. It remains a warm, shallow sea connecting the Arctic Ocean to the Gulf of Mexico, a 1,000-kilometer-wide corridor of life. The water is a clear turquoise, warm as bathwater, rich with nutrients upwelling from the depths. Coral reefs line its shores, not the corals we know, but ancient lineages that survived the Cretaceous and diversified in the stable conditions of this protected sea. And here, in these waters, swim the descendants of the hadrosaurs. Some ornithopods in the late Cretaceous had begun to experiment with semi-aquatic lifestyles, feeding on aquatic plants in swamps and rivers. In this timeline, freed from the pressure of mammalian competition, they have gone fully aquatic. They are streamlined, their bodies shaped like torpedoes, their tails powerful flukes for propulsion. They have lost their hind limbs entirely, vestigial bones buried deep in their flesh. Their forelimbs have become flippers. They breathe air, surfacing every 10 minutes to exhale through nostrils positioned high on their skulls. They communicate through song, haunting, complex vocalizations that travel for hundreds of kilometers through the water. They migrate seasonally, moving north in summer to feed on the rich algae blooms, south in winter to calving grounds in the warm shallows. They are 15 meters long, weighing 30 tons, gentle giants filtering plankton through modified dental batteries that have become baleen-like structures. They are, in every functional sense, the whales of this world. Above them, the pterosaurs still rule the skies. But they have changed. The largest, Eoraptor, has a wingspan of 20 meters. It is the size of a small airplane. It does not flap. It cannot. Instead, it soars, riding the thermals and trade winds across entire oceans, landing only once or twice a year on remote islands to breed. Its bones are so light, so hollow, that its entire skeleton weighs less than 10 kilograms despite its immense size. It feeds on the surface of the ocean, dipping its long narrow beak to snatch fish and squid, never landing on the water, always in motion. It has been estimated, by no one, because there are no scientists in this world, that an individual Eoraptor might circumnavigate the globe twice in a single year, riding the winds, a creature of the air more than the earth. This alternate earth is warmer, it is lusher. Without the rise of humans and the Industrial Revolution, the carbon cycle is unbroken. The forests are vast, continuous belts of green-breathing oxygen into the atmosphere. The silence of this world is deep and profound. It is broken only by the wind in the cycads, the crash of waves, and the deep, resonant drumming of distant feet on ancient soil. The amber light of the afternoon sun filters through the tree ferns, illuminating a world that never lost its magic. A world where the monsters never died, but simply changed, becoming more beautiful, more strange, and more enduring. The climate is stable. The carbon cycle, unbroken by fossil fuel combustion, maintains a gentle greenhouse effect. The polar ice caps are small, seasonal. The oceans are slightly higher, but not catastrophically so. The global temperature is perhaps 2 degrees Celsius warmer than in our timeline, enough to make the temperate zones lush and the tropics nearly unbearable for a human. But there are no humans. The seasons still turn, the monsoons still come, the rivers still flood and recede. But the rhythms are ancient, uninterrupted, predictable. In the forests of Southeast Asia, and in a region that would be Indonesia in our world, the nights are alive with sound. The calls of nocturnal theropods echo through the canopy, sharp, high-pitched barks and trills. Bioluminescent insects, evolved from ancient beetles, drift through the understory like living stars, their light attracting prey and mates in the darkness. The air is thick with humidity, warm as a breath, scented with orchids and decay. On the Australian continent, we isolated for 50 million years since it broke from Antarctica. Evolution has taken a unique path. Here, the dinosaurs have evolved into forms found nowhere else. There are marsupial-like theropods that carry their young in pouches formed from modified throat sacs. There are gliding herbivores with membranes stretched between elongated ribs, drifting from tree to tree in the eucalyptus forests. There are burrowing sauropods, miniaturized descendants of the giants, that live entirely underground, feeding on roots and fungi in elaborate tunnel networks. It is a world of evolutionary experimentation, isolated, strange, and wonderful. The silence of this world is deep and profound. It is broken only by the wind in the cycads, the crash of waves, and the deep, resonant drumming of distant feet on ancient soil. The amber light of the afternoon sun filters through the tree ferns, illuminating a world that never lost its magic. A world where the monsters never died, but simply changed. You're becoming more beautiful, more strange, and more enduring. Stand for a moment in the golden light of late afternoon on the plains of Africa. The savanna here is not grazed by zebras and wildebeest. Instead, herds of small bipedal ornithopods move through the tall grass, their heads bobbing as they scan for danger. They are the prey base of this ecosystem, filling the niche of antelope, and watching them from the shade of an acacia tree is a pack of Veloci sapiens, motionless, calculating, patient. The sun is setting. The sky turns orange, then red, then deep purple. The stars emerge, the same stars that shone on the Cretaceous, but now there are no artificial lights to dim them. The Milky Way blazes across the sky like a river of silver. The night is filled with sound, the hum of insects, the distant rumble of a thunderstorm, the calls of nocturnal dinosaurs beginning their hunts. The world is alive, it is ancient, it is enduring. In this dream, we realize something profound. The dinosaurs never truly ended. Even in our timeline, they are still with us. Look out your window, the sparrow on the wire, the eagle in the sky. They are theropods. They are the direct descendants of the survivors. In a way, the dinosaurs are still ruling. They just traded their teeth for beaks and their size for the sky. But in this alternate world, they did not need to trade anything. They kept it all: the size, the teeth, the dominance, and they added intelligence, complexity, beauty. They became not extinct monsters, but living masterpieces, a testament to the power of deep time to sculpt life into forms we can barely imagine. And as you drift into sleep, let this thought settle over you like a warm blanket. Somewhere in the infinite branching possibilities of quantum probability, this world exists. A world where the asteroid missed, where the dinosaurs endured, where the Mesozoic never ended but simply evolved seamlessly into something new. A world of scales and feathers, of giants and geniuses, of silence and deep time. It is a world we will never see. But we can dream it, and in dreaming we honor them, the lords of deep time, the rulers of the ancient earth, the dinosaurs. Deep time is a concept that the human mind struggles to hold. It slips through our fingers like sand. We live our lives in seconds, in minutes, in years. A century is a long time to us. A millennium is history. But 165 million years? It is an ocean of time so vast that we drown in it. Try to imagine it. Try to hold it in your mind. Close your eyes and picture a single day. 24 hours. The sun rises, crosses the sky, and sets. You wake, you live, you sleep. That is comprehensible. Now picture a year. 365 of those days strung together in a chain of seasons. Spring, summer, autumn, winter. The cycle repeats. Still comprehensible, now a lifetime. 80 years, perhaps. 29,200 days. The span of a human life, from birth to death, containing all the joy and sorrow and wonder a single consciousness can experience. Now multiply that lifetime by 1,000. 80,000 years. That is approximately how long modern humans, Homo sapiens, have existed as a distinct species. It is an eye blink, a flutter, a moment in the chronicle of the Earth. Now multiply that by 2,165 million years, the span of the dinosaur reign. It is incomprehensible. The numbers become abstract. They lose meaning. But let us try another way. Imagine standing at the edge of the ocean. Each wave that rolls in and breaks upon the shore represents one human lifetime. Wave after wave after wave, relentless, eternal. How many waves would you need to count to reach 165 million years? 2 million. 2 million human lifetimes crashing one after another against the shore. Can you picture it? Can you feel the weight of it? To the Earth, on the reign of the dinosaurs, was the standard. It was the status quo. Our own time, the age of mammals, is still just a brief chaotic aftershock. We look at the fossils in our museums, bones turned to stone, suspended in metal armatures, and we see monsters, we see failures. But this is the arrogance of the present. The dinosaurs were not failures. They were the greatest success story the planet has ever told. We measure success in human terms. We think in decades, in generations. A company that lasts a century is ancient. An empire that endures 1,000 years is legendary. But the dinosaurs reigned for 165 million years. They weathered climates we can barely reconstruct. They survived volcanic eruptions that turned the sky black for decades. They adapted to oxygen levels that swung wildly from suffocatingly low to intoxicatingly high. They lived through the slow dance of continents, watching Pangea tear itself apart, and watching new oceans birth themselves in the widening rifts. And through it all, they thrived. They did not merely persist. They flourished. They invented gigantism. They invented flight. They invented complex social structures, parental care, migration patterns that spanned hemispheres. They were not static relics. They were dynamic, evolving, endlessly inventive. Every extinction event that didn't kill them made them stronger, opened new doors, allowed new experiments. They teach us that dominance is not about strength. It is not about size. It is about adaptability. It is about the ability to change when the world changes, to find a way to breathe when the air is thin, to find a way to grow when the food is scarce, to endure the fire and the rain. There is a lesson here, written in stone and time. The lesson is not that the strong survive. Darwin never said that. He said that the adaptable survive, the ones who can bend without breaking. the ones who can shift their strategies when the old ways no longer work. The dinosaurs were not the strongest animals of the Triassic, they were the most flexible. And when the Crurotarsans, those mighty specialists, could not adapt to the changing climate, the dinosaurs stepped forward, not with force, but with resilience. And they held that throne not through conquest, but through continuous reinvention. The small bipedal hunters of the Triassic became the titanic sauropods of the Jurassic. The Jurassic predators became the intelligent pack hunters of the Cretaceous. They never stopped changing, never stopped experimenting. Evolution had handed them a toolkit, the air sac lungs, the upright posture, the rapid growth, and they used it to build 1,000 different forms, each suited to its time and place. As we drift towards sleep, let us hold this thought. The Earth does not hurry, it takes its time. It builds mountains grain by grain and wears them down again. It creates dynasties and lets them fall. It is a slow, rhythmic process of creation and destruction, endlessly cycling through the dark. Feel the earth beneath you. Feel its slow rotation, carrying you through the night toward the dawn. It is the same earth that carried the dinosaurs. The same rock, the same iron core, the same gravitational pull. The planet does not notice us. It does not notice our cities, our anxieties, our brief, bright civilizations. To the earth, we are a flicker, a spark. And when we are gone, as we will be someday, the earth will continue. It will heal. It will create again. The mountains we see today are young. The Himalayas are infants, barely 50 million years old, born after the dinosaurs fell. The Rockies, the Andes, the Alps, all children of the Cenozoic, the age of mammals. But the rocks beneath them remember older mountains. The Appalachians were once as tall as the Himalayas, and they have been worn down to gentle ridges over hundreds of millions of years. The earth breathes in and out. It exhales mountains and inhales plains. It is patient beyond measure. If the asteroid had missed, if chance had bent the other way just slightly, by a fraction of a degree, by a few minutes of rotation, would we be here at all? Would consciousness have arisen in a feathered reptilian mind instead of a mammalian one? We will never know. We can only wonder. We can only look back at the shadows they cast and marvel at the magnitude of what was lost. This is the great unanswerable question, the counterfactual that haunts paleontology. If the dinosaurs had continued, would intelligence have emerged? Not human intelligence. That is too specific, too tied to our particular evolutionary path. But intelligence of some kind. Self-awareness, tool use, culture, language. There are hints in the fossil record. The troodontids, those small, large-brained theropods with their grasping hands and forward-facing eyes. They were experimenting with something. Whether it would have led to sapience, we cannot know. But the potential was there. And if it had happened, if, in some parallel universe where the asteroid missed, a species of dinosaur had developed consciousness, what would their world look like? Would they have developed technology? Would they have built cities? Or would they have found some other way to organize their societies? Some way we cannot imagine because our entire concept of civilization is mammalian, primate, human. These are dreams, speculation. But they are beautiful dreams. They remind us that our path, our story, is not the only one possible. That the universe is vast enough to contain infinite variations, infinite timelines, infinite outcomes. In one of those timelines, perhaps, the dinosaurs still rule. And in another, perhaps, something we cannot even imagine has taken the stage. The world is quiet now. The great beasts are gone, sleeping in the stone beneath our feet. The dust has settled. The fire has cooled, but the legacy remains. The hidden truth of their reign is that life is resilient. Life is stubborn, life wants to continue, and in the vast silent library of the Earth's history, The chapter of the dinosaurs is the longest, most vibrant, most extraordinary tale of all. Walk into that library in your mind. Imagine shelves stretching to infinity, each book a species, each chapter an era. The dinosaur section fills entire wings, thousands of volumes, millions of pages. Each one documenting a life lived, an adaptation made, a challenge overcome. The mammals have a section too, of course, but it is smaller, younger, still being written. And at the end of the mammal section, near the very back, is a single slim volume. It is titled Homo sapiens. It is perhaps 300 pages long. We have existed for 300,000 years, give or take. If each page represents 1,000 years, our book is still very short, and we do not know how many pages remain. We do not know if we will fill another volume, or 10 or 100. We do not know if our chapter will be as long as the dinosaurs, or if it will end abruptly, another victim of chance and circumstance. But here, now, in this moment, we can read their story. We can excavate their bones from the rock. We can study their footprints frozen in stone. We can reconstruct their world from pollen grains and isotope ratios. We can, through the magic of science and imagination, bring them back to life in our minds, and in doing so, we honor them, we remember them. We ensure that their 165 million years were not in vain. The night is long, the stars are wheeling overhead, the same stars that looked down on the Triceratops and the Tyrannosaurus. The earth spins on, carrying its secrets into tomorrow. Whatever comes next will be just as wondrous, just as strange, just as beautiful. Look up at those stars in your mind. The constellations we see today are not the same as the ones the dinosaurs saw. The stars have moved slowly over the millennia. Polaris was not the North Star in the Cretaceous. The sky has changed, but the stars themselves, those distant suns, are the same. They burned then. They burn now. They will burn long after we are gone. And on some of those distant worlds, orbiting those distant suns, perhaps there are other stories unfolding, other dynasties rising and falling, other experiments in life, consciousness, complexity. We are not alone in time. We are connected through the fabric of the cosmos to everything that has ever lived and everything that ever will live. The atoms in your body were forged in the hearts of dying stars. Those same atoms once flowed through the veins of a Tyrannosaurus. They are ancient. They are immortal. They are you. So rest now. Let the weight of deep time settle over you like a blanket. Let the story of the dinosaurs carry you into dreams. They ruled for 165 million years, and then they fell, and then they rose again as birds, singing in the trees outside your window. The cycle continues. The story never ends. It simply transforms. Tomorrow, the sun will rise, as it has risen every day for 4.5 billion years. The earth will turn. The tides will ebb and flow. Life will continue its slow, patient march through time, experimenting, adapting, becoming. And you will be part of that story. A single consciousness, flickering briefly in the dark, but connected to everything that came before and everything that will come after. The dinosaurs taught us that nothing lasts forever, but they also taught us that while it lasts, life can be magnificent. It can be extraordinary. It can fill the world with wonder. Sleep now. Dream of deep time. Dream of worlds that were and worlds that might have been. The earth will keep spinning. The stars will keep burning. And somewhere in the fossil record, in the stone, in the memory of the planet itself, the dinosaurs are still there. Still walking, still breathing, still ruling their ancient world. And whenever you are ready to explore another world, we will be here. And whenever you are ready to explore another world, we will be here.